Hey everybody, Mr. Piercy here, and what we're going to be looking at today is another type of shortcut to show why triangles would be congruent to each other. Now, this would work better if we were in a class where we had a whole lot of people doing the same thing at the same time. But since I'm the only one that's able to demonstrate this right now, you might want to try and just do it on your own. Follow along as we do this video. Otherwise, you can just kind of watch and see what we're going to be doing. Well, what we've seen already is that if I have three corresponding sides from figure to figure that are the same, then the triangles have to be the same as well. Well, that's not the only shortcut that we have. The next one that we're going to look at is something called a side angle side, where I have two sides and an angle included in between them. So that's why the A is in between the S's on either side, because the angle physically on the triangle has to be in between the two sides that we're going to be looking at. So here I have two segments that we're going to be using to make the triangle. So I'm going to use my compass, my straight edge, and my pencil to help us do this construction. So to begin, all I'm going to do is copy. I'm going to just make a segment. I don't know how long it is. I'm just drawing a segment. And I'm going to use the bigger of the two segments that we have here. I'm going to look at segment AB. And I'm going to go ahead and copy that segment. So here is A and B. So since I have point A here, what I'm going to do now is I'm going to copy angle A. So I'm going to copy angle A. I'm not very good doing the compass with my left hand. And oops. That looks good right there. And so we have that. Now I can go ahead and take my straight edge and I can draw in that side. Now I don't know how long it's going to be, so I'm going to just draw it that long. And now I'm going to copy segment AC. So from here, let's copy segment AC. So from point A, there we go. So at that point is where C is, and I can close up the triangle. Now, if we were in a classroom where everybody had the same dimensions, if I gave everybody these three things here, whether you put point A here on the left side the way I did, or you did it on the right side, everybody should wind up with a triangle that is congruent to everybody else's. Now, unfortunately, we don't have 20 kids around us to necessarily compare everybody's triangle to, but go ahead and just try doing it on your own. Maybe you and a partner, and just draw a couple segments, draw an angle, and try constructing your triangles and see if you get something different. Okay. Now, the one thing that I'm going to show you here is we're going to change it up just a bit. Now I'm going to take this point out. I'm not going to call that point A anymore. I'm going to call this point B. Could we construct a triangle where it's congruent, where instead of having the angle in between the two sides, what about if I said, and I'll put it down here, what if I said side, side, angle, where the angle is not going to be included in between the two sides? Side, side, angle. Will that work to show whether I have congruent triangles or not? So let's go through the process here. I'm going to again copy the material that we have. So I'm going to just start with the line segment, copy segment AB because that's kind of the bigger segment here. So copy segment AB. So here's point A, here's point B. I'm going to copy my angle again. That looks good. So copy angle. There's one part. And measure this distance here. And do the same thing here. So now I'm going to go ahead and draw in this side of the triangle. And again, I don't know how long this one necessarily has to be, so I'm going to draw it a little bit longer than it probably really needs to be. But now we're going to copy segment BC. Now because the angle is not going to be included in between the two sides, we're going to have segment BC coming here. So what I'm going to do is I can see, look, I have, this is how long BC is, but if I continue around, I can see I could have point C in two different places. Here's point C here, here's point C. So I, in my own construction, let alone what anybody else would be doing, in my own construction, I can show that I have two possible triangles instead of just one that would be congruent all the time. BA is still the same length, and BC is still the same length. So BA is clearly shared because we see both triangles using the same length, and here's BC and here's BC. They're the same length because we just copied the segment. And obviously angle A is the same, but we can clearly see I have some short little obtuse triangle here, and I have a bigger obtuse looking triangle here. So if the angle is not included in between the two sides, we cannot use that combination of parts to show that triangles are congruent to each other the way that we could if the angle is included in between the two sides. So here, side-side angle works. Here, I'm sorry, side angle side works, but side-side angle unfortunately does not produce congruent triangles. So that is kind of what I wanted to show you here for this one. Why side angle side does actually work. But until next time, guys, thanks for watching, and we'll be back later with more geometry videos. So take care, guys. Oh, you can stop.